Okay, great. So this talk is, there we go. This talk is all about building QGIS or QGIS plugins with Python. The slides are at bit.ly/NACIS23 QGIS plugins. That just links to this Google Slides document. Or you can scan that QR code. So yeah, so like Jana said, my name's Will. I work at a company called Werobots. There's a few points of contact on there if you want to reach out. And again, another chance to get the slides. So Werobots is a startup from the creators of the open source Apache Sedona project. Anyone using Apache Sedona or looking at it? A few folks? Okay, cool. So Apache Sedona is really all about adding geospatial analytics functionality to distributed data processing frameworks like Apache Spark or Apache Flink. And you get a Python, Spatial SQL, or R API for working with that then. So really when you have large-scale data to fit into some geoprocessing pipeline. It's only my second week on the job, so it's a bit of a learning experience for me. So I'm trying to document my process of learning Sedona and Werobots a bit. So earlier this week, I did a video, just kind of an intro to Apache Sedona. So if that's interesting to you, you can check that out on YouTube. But this talk is not about Werobots or Apache Sedona. We're talking about building QGIS plugins. So this is, roughly the outline that I want to go through. First of all, why build a QGIS plugin? A little bit about the plugin ecosystem, what plugins are out there that folks find useful, and then talking about how to build a QGIS plugin. We're going to skip the demo part today. I went through this earlier, and I think there's plenty to talk about without going through a demo. So first of all, how many people are using QGIS or QGIS? Yeah, okay, that's a lot of folks. Cool. How many people use QGIS plugins or have installed a QGIS plugin? Cool, it's still a lot of people. How many people have written a QGIS plugin? A few folks. How many people have thought about it or want to or have a use case? Okay, cool. So QGIS describes itself, it's from the website, as a free and open source geographic information system. I won't go through this thing. Most folks here know what QGIS is and appreciate the value of it. I will highlight though that and this is one I added that's not on the website, I think of QGIS as like this extensible platform. And a platform because I can build things on top of it, right? I have the ability to build plugins, the Python API. Also, I was watching Marco's talk. He's the chair of the QGIS Foundation from Neo4j, and he was talking about some of the data that they look at. They have over 700,000 daily active users. And the budget for QGIS is like $200,000. So that's pretty amazing, like the power of the open source ecosystem to support that. So cool, so why should we build a QGIS plugin? Well, I'll talk a bit about like my motivation and why I started looking into this. So I mentioned that I work at Werobots and that this is my second week on the job. For the 8 years before that, though, I worked at Neo4j, which is a graph database. Anyone using Neo4j or looked at that at all? A few folks? Cool. So my motivation was really, okay, can we take the power of this like open source graph database technology and bring that into the GIS ecosystem? And Neo4j uses a query language called Cypher, which is a bit different than SQL. So it's a bit different than just kind of like plugging it into some connector for QGIS that speaks SQL and you get tables, because we don't have tables, right? We have graphs. So trying to think of how do we kind of bring that in. If you were at my talk at NACIS last year, I kind of used this to introduce the concept of graphs. So apologies if you've seen this before, but I thought this like really resonated with me. So I'm going to do it again. So Tobler's first law of geography is basically that everything is related to everything else, but things that are near are more related than distant things. So last year we were in Minneapolis for NACIS, and So you can say, okay, like Neo4j headquarters in San Mateo, that's more similar to other Bay Area cities than, say, San Mateo is to Minneapolis. And we can quantify that with distance, right? So San Mateo to Minneapolis is like 1,500 miles, and so on. So we can put like attributes on the relationship that connect these nodes, and like that's a graph, right? A graph is nodes that are the entities, relationships, connect them. And I thought, wow, this is really, like a fundamental idea of geography as this idea of thinking about graphs. And someone last year at NACIS pointed out to me that, Tolbert wasn't talking just about like physical distance. He sort of was getting at like human geography, cultural differences as well. Like bring your own distance metric, not just sort of physical distance. So fundamentally, what is a graph? Well, a graph, like I said, is this data structure. We have nodes. These are the entities, relationships, connect them. Graph databases use what's called the property graph data model. So we have a few things that define the data model that we work with. We have labels on the nodes that describe like the type or the way that the grouping of the node. You can think of that as kind of similar to like a table from the relational world. Relationships have a single type and direction. And then for our data, our attributes, we can store arbitrary key value pair properties on nodes or relationships. A related term that you might have heard about or hear a bit about is this idea of a knowledge graph. And I think of a knowledge graph as really just like an instance of a property graph. And the idea here is that you're working with some canonical representation of a thing. So this example, this comes from data from the New York Times API, and we're modeling that as a graph. So we have things like articles. We know the people, the places, the organizations that are mentioned in the article, so that when we have, like this one here, a topic node, and we have an article about, this is United States politics and government. When we have another article that has that topic, we don't create a duplicate of the topic node, we create another relationship to it. So we have some canonical representation of the thing. When Google released their knowledge graph in, it's maybe like 2012, they put out this blog post talking about things, not strings, that I think was really helpful to have a framework for how to think of like what is the value of a knowledge graph. So let's look at a couple of other geospatial data sets that are out there. So OpenStreetMap, this is super powerful data set. I've heard this described as the most valuable data set in the world, which I would probably believe. If we look at the data model for OpenStreetMap, so we have nodes. These are the sort of individual point geometry like representations. If I'm mapping, say, like a sidewalk or something, it's going to be made up of a bunch of nodes into a way. So a way is just a grouping of nodes that define like a sidewalk or a street segment or something like that. And then a relation is a way to kind of group those ways into like, say, a longer piece of an interstate or something like this. And like this is also a graph, right? We're talking about nodes and entities and how they're connected. Like this data model is fundamentally a graph. How about this one? This is a map that John Wesley Powell presented to US Congress in 1890. And this was his proposal actually for how to create states when they were looking to expand into the western parts of the US. And it was all based around watersheds. So these are the drainage basins in the West. This is also a graph, right? Because all of these basins drain into another basin until the water empties into the ocean, right? That's a graph. The nodes are the watersheds, and where they flow, that's the relationship. A good data source for this comes from the Hydro Basins project, which has several different flavors of this. You can see how these sort of larger basins can be subdivided, and as here we're having like a stream and a river flow, we can see the graph connection as sort of the river flows from one basin into another. Someone from the Neo4j community took this data from hydrosheds for the whole world at the most fine-grained level, loaded it into Neo4j, and built this web application that allows you to click on a map and see all of the downstream and all of the upstream watersheds for anywhere in the world, which I thought was super cool. Also, earlier this week, I did a workshop online using this watersheds data in Neo4j to build kind of a similar thing. So if that's interesting, the recording of that is available too. So okay, we talked about like a whole bunch of geospatial data and data models that are inherently graph in nature. But then when we fire up QGIS and load in data, we get tables, right? And that's how we work with data in the geospatial world for the most part. So this was my motivation for looking at building QGIS plugins. Like, can I bring in this concept of graph databases, Cypher, this query language, which we didn't really talk about the advantages of it, but can we bring that into sort of our GIS tooling so that we can start thinking and working with data as a graph? And so last year at NACIS, I showed some Python scripts of how to do this in QGIS with the Python API. So Neo4j has a Python driver, so basically a Python package that I can use to send queries to the database. That makes it really easy to work in QGIS to sort of pull data in and modify layers and things like this in QGIS. Cool, so let's talk about the plugin ecosystem. But first, maybe let's contextualize this a little bit. So this is a map that I created. I think probably like a lot of folks, I like to just create maps of places that have some significance to me. So I used to live in Medellin, Colombia, and spend some time traveling around. So this is a map of the Sierra Nevada to Santa Marta National Park in Colombia, which is really an amazing place. This is the tallest coastal mountain range in the world. So you have like these huge mountains, then jungle, then beach. It's really quite amazing. There's a hiking trail here to a lost city of Tirona as well that's kind of highlighted on the map. I call these my Null Island Labs projects. They're just kind of fun side projects, no real purpose. And like a lot of folks know here, when you go to make a map, everyone has sort of their own data sets they like to use, different tooling, different kind of pipelines for how to do that. And so when I was thinking about, well, what are some of the tools that I used to do this? Well, I used QGIS to kind of work with all the different data. Data came from Natural Earth, Open Topography, Protected Places, OpenStreetMap. I used a QGIS plugin called QuickOSM to pull in that OpenStreetMap data. That's actually what the screenshot from QGIS a minute ago was. I used Edward, which is this shaded relief machine learning model that I think Bernie Jenny released last year at NACIS. So it's this machine learning model that's trained on like hand-drawn Swiss topo. So you give it a DEM and you then get a raster of what looks like hand-drawn shaded relief. Pretty amazing. And then use another QGIS plugin to get like satellite imagery, blended that in Photoshop, and use Illustrator to kind of work with vector styling. So there's a lot of different pieces here, and they all kind of have to work together. So those are kind of an idea of like what are some of the QGIS plugins that we can use. So yesterday I asked the social medias, what are your QGIS plugins that you're using? What are your favorites that are out there? And I got some interesting responses. Some that I knew about and used, and some that I had not heard of. So I was thinking like, there's this real rich ecosystem of QGIS plugins. Like, how do we sort of like classify these from? Is it like based on like use case or like how they work with data? And this is kind of like roughly what I came up with as a way to kind of categorize these. I don't know if this actually makes sense, but just kind of what I was thinking about. You have sort of like your data management plugins that allow you to pull in data from other sources, these sorts of things. Then you have what I call vector processing and data visualization, where you're sort of implementing maybe geoprocessing algorithms that aren't natively available in QGIS, manipulating vector layers to give you different visualizations. You have things like publishing or like pipeline plugins that allow you to export to some external system. And then really there's these domain-specific ones that add functionality for like very technical domain-specific use cases. So let's look at some of the data management QGIS plugins that are out there. So I mentioned QuickOSM a minute ago. This is super powerful. You basically give it a query to run through OpenStreetMap. It uses OpenStreetMap's Overpass API, and then boom, you have new layers in QGIS based on the result of your query. So I use that in the Sierra Nevada to Santa Marta map to find lots of different things. The Tyrona Trail was one that I used on there. Basically, any of the points of interest that are highlighted on there came through QuickOSM. Then we have these processing and data visualization plugins. So these are things like QGIS, which is really this huge collection of all kinds of different like vector layer operations. I think of this one as kind of like the standard library for QGIS, really, that kind of implements a lot of things that are kind of not natively available there, but I imagine a lot of folks are using QGIS. One that someone had mentioned to me yesterday was Cartogram 3 for creating cartograms, which I was not familiar with before. This one looks pretty neat. And then this idea of the publishing and pipeline plugins. So one here is QGIS to web. So we basically look at what layers we want to export, configure some basic styling, and this will generate open layers or leaflet files for us that it's like there's static web files that we can then serve up to have a web map. Another one is the Add to Felt plugin. So this gives us a little button here in QGIS to basically export our data and create a new map in Felt. Anyone using Felt? Just curious. I know there's a few Felt folks around. Cool. And then this idea of domain-specific plugins. So if anyone's read the QGIS for Hydrological Applications book from Locate Press, they use the PC raster tools in this for doing lots of like watershed analysis and things like this that are useful beyond just hydrology, but I think largely like ecosystem modeling in general is kind of how I think about that one. So that was just to look at a few plugins from the ecosystem. There are, I want to say hundreds at least, maybe thousands, I'm not sure. Let's take a look at how do we actually build a QGIS plugin. And so I guess the first step is to kind of ask yourself, what type of plugin do we want to build? And you'll see why in a minute this is important. So there are like the GUI plugin, so where we have some graphical user interface that we need to design and control. And then there are what are called processing frameworks, where we are more like implementing a processing algorithm. And then we're going to be working with the PyQGIS, the Python API for QGIS. Basically, any of the button clicking that we can do in QGIS, we can do that in Python. So adding new layers, adding data, adjusting styling, all of this we can do in Python. And that's sort of like the core like functionality of how we're going to implement our application. We can also use other packages. So like for the Neo4j example, we're pulling in the Neo4j database driver, the Python driver for Neo4j, so I can send queries to some external system, these sorts of things. And then if we're using any sort of user interface elements, we work with a system called Qt, or the Python version, PyQT, and this is the system that controls all the user interface elements in QGIS, which we have access to in our plugins. So one way to get started building a plugin is with a plugin. There's a good joke there, and I don't know what it is, but so we can install this plugin in QGIS, and then this gives us some templates for creating sort of like blank plugins. If we go the GUI plugin route, well then we have to work with this like Qt designer thing, because it kind of puts the responsibility of managing the plugin on, or the user interface for the plugin on the designer of the plugin. If we do a processing plugin, we don't need to worry about this visual way of designing our Qt interface. We can do all of that with code, but there's less sort of GUI elements that we can control. Another important distinction is that with the GUI plugin, we can't say like add a new processing algorithm that then like pipes into other functionality. So that's something to think about as well. These I think are the best resources that I found out there for building QGIS plugin. Well, I guess both options for building the GUI and the processing one, but then also in general for using the Python QGIS API from Ujjwal Gandhi or Spatial Thoughts, spatialthoughts.com. If you've probably seen his content out there, he publishes sort of the whole course for free. It's really quite impressive. Cool. So that's all I have. Again, some points of contact. Feel free to grab the slides there. And if anyone wants to chat about anything related to Apache Sedona, Neo4j, or QGIS, please reach out. Thanks.
I think we have time for like one quick question if we steal from Ross's presentation since he took so little time.
I'm curious, how would you characterize, that was a great talk by the way.
Oh, thank you.
How would you characterize the learning curve for doing a plugin? Is it steep and short? Is it shallow and long?
So the like plugin builder template thing really helps. There was a tweet I saw the other day that I took a screenshot of, and I was actually going to put it in here, but it was from someone, I can't remember his name, who shared a plugin that he wrote, and it was literally the first Python that he had ever written was like creating this plugin. And so I think having that template like helps a lot. The like developer experience, I think, which is like the process of like how do I like deploy this and how do I think of like bringing in the packages, dependencies that I have is a little daunting, I guess, if you're kind of new to all of that. There's a talk at Neo4j earlier, again, I can't remember who this was from, but they built some tooling to kind of smooth that piece out. So I'd say that's probably the roughest piece is like the developer experience piece around it, yeah. Thanks.